So now I'm going to talk about random access file. Okay, in the previous lecture we talked about sequential access. So sequential access, and today we will discuss how the random access works or what is random access. So in sequential access, just to recap, it starts at the beginning of the file and go through the data in the file in iteration. Okay, and in order to reach to the end of the file. Okay, for instance, to access the 100th entry in the file, we have to go through the every entry till 99. Okay, from 1 2 3 4 till 99th entry, and then to the 100th entry. So this is sequential access. In the random access, access data in a file in any order. We can directly go towards any specific position in the file. Okay, using an offset. So that is the random access, which is much faster. So in order to perform the random access in a file, okay, we have file pointers. So each file object, okay, whenever we create an object, input object, or the IF stream or O stream object, we have some file pointer associated with it. Okay, this is there are two pointers associated to each one is get pointer and the put pointer. Actually, do not get confused with this pointer. These are not the pointers which we have discussed so far in our course. Actually, these are the the pointer to navigate to certain position in the file. Okay, it can be cursor. Whenever you open any text file, maybe an MS Word file or maybe any other file of any other type like PowerPoint or Excel. Okay, you have a cursor blinking over there. So that kind of cursor which tells that there is a control right now for reading or for writing. These are also called the current get position or current put position, and or may simply the current position. And these values specify the byte number in the file where reading or writing will be performed. Okay, so because the data in the file is composed of the data, and the data is stored in the and each data item has certain size in the file. Okay, so that's why we have to manipulate the access in the terms of the bytes. Okay, so what number of bytes, what number of bytes I have to skip, in what number of byte position I have to move in order to perform reading or writing operation over there. So file pointers. Okay, so we have seekg and tellg and seekp and tellp. So G, let me make it very clear that G means get and P means put. Okay, get means reading and put means writing. Okay, so not to be confused. Okay, and G mean get, that means reading, and P mean put, that means writing. Okay, so seekg and tellg functions allow us to set and examine the get pointer, that is the reading pointer. Okay, we want to read from the specific position, and seekp and tellp functions perform the same action on the put pointer, that we want to start writing from that particular position. Okay, so we'll explore these two in the detailed examples today. So the get pointers. Okay, seekg. Okay, so what is the purpose of seekg? It navigates the read pointer to the desired position or byte in the file. Okay, so actually seekg is a kind of helper. It helps you to navigate. It helps, yeah, or it takes the read pointer to that particular location or the desired location. Okay, and similarly tellg returns the position of the current character in the input screen. Okay, so you can observe that in your Microsoft Word file, for instance, the cursor is blinking somewhere. So that cursor telling what is the current character over there. The same job is performed by tellg in the file access mode. Okay, in C++. So it returns the position of the current character in the input stream. Where is the current cursor right now? Okay, so similarly, and the put pointer. Okay, the seekp, it helps, it navigates the right pointer to the desired position or byte in the file. Okay, and similarly the tellp returns the position of the current character in the output stream. Okay, so the tellg tells the current position of the character. Okay, in the returns the position of character in the input stream, because we are reading, so we are using the input stream, and because we are writing, we are using the output stream. Okay, so O stream object. Okay, so it tells the position of the current character in the output stream. Okay, so I will discuss some of the rules in detail. Okay, with examples as well, and the rules on below slides are same both for seekg and seekp. Okay, so I may talk about using either of the function. specifying the position. Okay, the seekg function works in two ways. So it can have it has two arguments, but you can specify one argument as well. So single argument represents the position from the start of the file. Okay, so if g, so in this example I have given seekg, and I have supplied the value 0 as a single argument. Okay, so it starts from the beginning of the file. Let's suppose this is my entire file. Let's suppose this is my entire file, and definitely the file begins from somewhere and ends at somewhere. So if I write seekg of 0, it means that it moves the get pointer to the start of the file. Okay, and in this way I can perform the reading from the start of the file. And if I if I supply two arguments to seekg, where the first argument will tell how many bytes to skip or to start reading, and the second argument iOS uh, scope is related beg means begin. Okay, so it means that skip 10 bytes from the start of the file. Okay, so it is actually the long value, the started long value, because normally the files are too large in size. Okay, that's why we specify the long value. It's not the int or shorts value over here. It should be the long value. If you want to supply some variable over here, that variable should be of data type long. Okay, so if with this seekp means that moves uh, the put pointer, okay, the right pointer to the 10th byte from the beginning of the file. Okay, so maybe I have more sophisticated examples in the subsequent slides. Okay, so there are three possibilities for the second argument: beg for beginning of the file, cur for the current position of the file, and end is the end position of the file. I have another example that seekp -10 and iOS end means from take the read the put pointer to the 10th position from the end of the file. So -10 means take from the end of the file. Okay, so if I write -10 beginning, that it may not work, because from beginning it should be from the value should be in the positive. It should be positive value. Okay, so specifying the position. Okay, so from beginning it will set the offset from beginning of the file, ending is end of the file, and current means where the current cursor is standing right now. From there we can set maybe the plus we can set the plus value, or maybe set the minus value as well. The summary of seekp and seekg is that seekp and seekp arguments, it requires offset and the flag. Okay, the flag can beginning, cur at the end, and similarly offset is the number of bytes to skip. That is a long value. Okay, so let me go towards the example. Okay, so demonstrate the working of seekg and tellg. Let me go to this file called random access seekg tellg.cpp. seekg and tellg.cpp. So let me first explain this code. Okay, so in this function, in this program, we want to demonstrate the working of both tellg and seekg using um, this string of characters, which is this string which is written in a text file. Okay, I will read from this text file, which contains this character over there, and these are total 22 characters. Okay, and it's stored in the data called a file called mydata.txt. Let me paste this value over there if it's not already stored over there. My data, actually it's already there. Okay, so I have created an object of iostream because I want to read. Okay, input stream, I want to get the input, okay, from the file. I want to read from the file. Okay, okay, and so I will explain line for each statement. Okay, so first I've demonstrated the position of the pointer at the start of the program. Okay, whenever the program starts. Okay, so ideally the cursor should be on the start of the file. Okay, so file file obj is my object dot tellg tell the first value. Okay, it should be 0. So position of pointer at start of the program is 0 because ideally at the start of the program the cursor should be ideally set to the 0 position. Okay, then what I'm doing actually in next statement I'm doing file obj.seekg and I'm passing two arguments 8 and iOS at beginning. It means move to the 8 byte from beginning of the file. It means it will move to the 8 byte and read the ninth value, the value at the ninth byte. Okay, so value of the ninth byte is, what is the value of the ninth byte? Okay, is according to the output this f. How it is f? Let me count. Okay, we have 1 2 3 4 5 6 7 8 9. So cursor is set over here and that's f is my ninth value. That's why I get 9 over here. Okay, and now if I get and that's why I'm displaying the value. So cursor have moved to the 8th position and I get the value. Then actually the next value is red, and using the get function the next value is red, which is this value. I hope you can see the highlighted f in my on my screen. And next now the current character at the current position is f, because when this get function has been executed, the cursor has moved towards the one step ahead because I move over here now. Okay, so now the position is number 9. Okay, previously the position of the cursor was 8. Okay, and it was reading the value at the ninth byte. Okay, because this is a string, but each character takes 1 byte. Okay, and in this way I move to the 8th position and read the ninth value. And now what I want to do is I want to see that what is the current position of the cursor and what is the value right after that cursor value, right after the cursor. So that I written file obj.get and it tells what is the next value. Next value is actually a. So it's the after f it's a over here. So why I typecast to character? Okay, if I don't typecast to character, then actually it's the ASCII value and it gives me 65. 65 is actually the ASCII value of A. So I have to typecast the ASCII value to the corresponding character value. Okay, now what I want to do is actually I want to print entire rest of the values. Okay, I want to print fast Islamabad. Okay, so because the cursor is now moved after A, right now it's blinking over there, so I have to move 2 steps back. I have to move 2 bytes back. Okay, that's what I'm doing it. That's doing file obj.seekg -2 iOS current. So from current position, move two step back. Okay, it's current position over here. 1 2 move 2 step back, and move to, after moving to 2 step backs, read character by character. Okay, so and to demonstrate all the values, to read while it becomes end of the file gets true. Okay, so so when I move 2 step back, I am reading character by character and then displaying this thing. That's why I get output called fast number. Oh, there is a garbage value over here as well. So maybe I discussed in my previous lecture as well, because the end of file doesn't become true. End of file cursor doesn't become true when it reaches over here. Actually, when it finishes reading and it cannot find the next character, that at that instance of time, end of file becomes true. Okay, so that's why there is, and because there is no value after this in the file, in the text file, so that's why actually the double quotes are just in this code. There are no double quotes over there in the text file. Okay, so because there's no value over there, that's why the get function gets garbage value. Or you can omit the garbage value by performing small if check over here. Okay, so now the current position, now because I have reached to the end of the file, so current position now set to -1. So -1 says that now I have the stream. It says that the end of file has been reached and the stream has reached to the final position. Okay, so now initially I will talk about the error bits. Okay, so now whether the stream is in good position or the bad position, the good position or the bad position, it means that whether the stream is in the position or in the mode to perform some reading or writing over there as well at current position. The current position is -1. Okay, it means there is no more values to be read or to be or can be because I am just reading. Okay, so there is no more thing to be read more. Okay, that's why it's -1 over here. So if I check o file obj at good, actually it is giving me the bad bit. Okay, because the stream is in not in the good position to perform the further reading. There is no more thing to be further read. That's why it gives me the bad bit over here. So in order to solve this bad bit thing, to make it the good bit, okay, I have to clear this. I have to clear the file. I have to clear the stream. Okay, clearing the stream actually will make the end of file marker um, um, to to move to move one step back. Okay, so that it can navigate now. If I do this navigation thing, okay, seekg to iOS back. Okay, if I just copy and paste this thing over here before the clear thing, so it's not going to work. It's not going to work because the stream is not in a good position, the string in the bad position. Okay, so you can check it. You can just copy this line from here and paste over here. This navigation will not be performed because the status of the stream is bad now. It's not the good now. Again, I repeat, by bad I mean that it cannot perform for the reading over here. So I have to clear the stream. Okay, so when I now after clearing it the stream, okay, when I do that, okay, so the current position of what I'm doing actually, I'm telling the current position of the cursor. So the current position of cursor now 22, because there are total 22 characters in my this in this particular string. Okay, so now it moves to the 22nd correct 22nd position, and now I can move to the 0th position, first position, and then after moving to the first position, I'm getting the entire line as I did explain that line in my lecture number 1, and then I'm displaying the entire line over here. So in this way, we have seen in detail how to perform the tellg and seekg, okay, while getting the data from the file. Okay, I hope you must have learned. So I have another example for the seekp and tellp, and which may explain more in, which may clarify some of your more concepts. seekp and tellp. So this is quite interesting. If you just keep playing with this, you will learn a lot. Okay, and I have more examples for today as well. Okay, so again, I repeat that the tellp provides the current position of the right pointer, and seekp helps to navigate the right pointer to reach to that particular position. Okay, so in this case, okay, I opened the my data file in the out position, that I will using the OF stream, that output stream, that I will write to this data file. Okay, so let me first drop this file so that I don't have any file over here. So I should have fresh thing. Okay, so when I now I have, as you see that deleted a file. There is no file called my data over there. So when I execute the statement, okay, the my data file it gets created. Okay, then if I now if I execute this command, definitely it should be the of the 0th position. Okay, then after that I write this line, welcome fast newses. Okay, and tellp should be on the 18th position, because I have performed the writing till over here, and now the stream is ready to be written from this point onward. Okay, so that's why it is giving me 18 over here. Excuse me. That's why it's 18. And similarly, now I'm asking to go five steps back, because 5 steps back means 1, 2, 3, 4, 5. So I want to overwrite this newses word with Islamabad word. So its length of newses is 5. I'll move 5 steps back, and then I will display. Okay, and then I am overwriting from beginning. Okay, from begin I am overwriting the word from welcome to small caps to the bigger caps. Okay, and that is the agenda of this program. I hope you have understood this concept. Okay, so next I will go towards end of file in random access. Okay, so if end of file is set to true, when it reaches to the end of the file, okay, the file has been exhausted. Okay, then it must be cleared before performing seekg or seekp task. Okay, so otherwise you cannot perform this task because the stream is not in the good position. Okay, let me explain this thing with example. Clear functions by clear the stream that makes UF as false. And when when end of files marker is set to false, the pointer then can be navigated because now the stream has moved to the position of the good bit. Okay, so random access EOF marker.cpp. Let me open this file. EOF marker. So what I'm doing in this code is that I have opened the file in and using the ifstream class. Okay, then I will be perform reading on this file. Okay, so this file is my data again, that space welcome past Islamabad, that's written over there. And the position of the read initially definitely position is initially is definitely as the 0.0. Okay, then and then what I'm actually what I want to demonstrate is that when I reach to the end of the file by executing this loop, then what happens? Can I perform? What is the nature of the bit? And can I perform this seekg position, seekg operation over there or not? So I have written this code intentionally so that I can reach to the end of the file. Okay, so this code has already been discussed in the previous examples. So let's go ahead. So current when I read to the end of the file, the current position is actually -1. It means that I have read to the end of the file. There's nothing more to be read. Okay, now if I check the file update at good, whether it's the good position or the bad position. Actually, that it should say the bad position over here. It should say the bad nature of the bit is bad now because I cannot perform further reading. It has been exhausted. Okay, and similarly the end of file bit has been set to true. Now when I'm performing these actions, file obj at seekg move to the beginning of the file. Okay, and perform reading of the entire line from there. Actually, you see it I'm I cannot see anything, any output over here. So I have to clear the string. Clear the string actually makes the end of file marker to the false state, and definitely in this way the string becomes okay for the working. Okay, now if I check the state of the bit, it come to the good position, and end of file marker has become false as well, and the current position is definitely towards from, because it was in the false position from -1. It has moved towards that particular bit, which was that particular byte, which was actually occupying the last character in that file. Okay, that was from Islamabad. Okay, that D. And then now you can see that after clear. Okay, after clear, I can perform this operation. That as a result, I can see this line over here, which is being published and using this line operator. So in this way, I have tried to demonstrate end of file marker in detail and try to explain different error bits as well. So now I go towards the last bit of my today's talk, that is execution time comparison in data access, sequential versus random. Okay, actually the idea behind this code is that I have discussed that sequential access has to iterate through each line, each statement of the program. Sorry, each line of the text file, and random access can directly go towards some specific byte or specific position in the text file. Okay, so and I already explained that sequential is slower compared to the random access, and apparently it looks like as well. So, and yes, that's correct. Okay, maybe you're thinking that it is faster. Yes, it is faster, but the idea of this program is to perform the speed testing. Okay, execution time comparison. Okay, normally actually this is the era of data science and big data. Okay, there are large amount of data available out there. Sensors are reading social medias, Facebook, Twitter, WhatsApp. People using so much social media. People browsing. So data is coming, okay, and it's being written to the different maybe cloud storage media or database management system, the text files, okay. So that's why we have large amount of data over there. And in order to get useful information from data, okay, we have to iterate those files, okay. So if we perform the sequential access, okay, then it's very slower, okay. And definitely we have to perform random access the files normally and gigabytes, terabytes files, okay. So in this example I have generated a data set, okay, which contains all the digits of five, of length 5, okay. That's from 10,000 to 99,999, okay. So I've generated the data set and I want to see how much time it takes, my program takes, when I read to the end of the file using random access mode and sequential access mode. Similarly, in the next bit I will perform the search for words, okay, both using the random and access file. I have compared their execution time. So first of all, let me go to this file, speed test, random access file, eof.cpp, okay, speed test, random access file, random access file. Okay, let me first of all, let me copy this is my random, and let me copy my uh, sequential one as well, so that I have both the data set open, both the uh, codes open, so that I can instantly execute both the code and compare the execution time. Okay, so this is the code for the random access file. Okay, in the random access file, okay, so I want to, this is my last number in the file. Okay, so I have this file. Let me show you the file as well. So this is my digits. It's a text file. Okay, the numbers are start from 10,000, and the last value in the 10,000 actually is last value in the file is 99,999. Okay, so this, because since this is last value, that's why I want to read, I want in the random access mode, and I've set this num to search as last value, okay, because there are is 5 bits, okay. So I have to and each line takes 5 bytes, and the sixth one actually for to move is a backslash n character to move to the next line. That's why I have to multiply this the 6 in order to get the pointer position, that what is the byte position of that particular value. Okay, so I open this file. Okay, so for this time comparison I'm using the high resolution clock. Okay, and if you're unaware of this thing, that forget it. Okay, I'm using the auto type states that data type of this variable is set during execution of the code. Okay, if you're not because we have not formally taught you this kind of thing, so you don't need to worry about this kind of code. Okay, um, okay, so I'm, because I know what byte position to move, so that's why I written the byte position over here. And I said some beginning to move to this, the cursor should move to this number of byte, okay, this position of byte from beginning of the file. Okay, then display the thing, get the value over there using the get object, and then display the line over there. And then I compute the time in nanoseconds and display how much time it takes in nanoseconds. Random access mode takes in nanoseconds. Let me go to the random access, sorry, sequential access mode. Okay, over here, because in sequential access I have to iterate through each line. Okay, so that's why I'm doing I'm doing a while loop over here in order to say the marker should move line by line till the end of till I reach the end of the file. Okay, until end the file become true. Okay, so I'm doing character by character. I'm reading character by character. Okay, because I have to character. If I can read line by line. I can read character by character as well. Similarly, I can read word by word as well. So I will do the comparison using the both thing, and I'm recording the time in nanoseconds. Okay, so let's see how much time it takes using the random access mode in nanoseconds. So it takes 44,818 nanoseconds in order to reach to the final bit, to the final value in that file. That's 99,000, this particular value. So it takes 44,818. If I execute it again, it may be a different value, because this value is varies, because varying of value has happened because of the different factors on my system. Okay, different processes executing the same time, and definitely I can I can use an APIs to exclusively get the tick time of the number of CPU cycles. You can use those routines as well. And similarly, this time can vary based on the number of based on CPU power, RAM, this kind of stuff as well, of system as well. So it has taken, it had taken 66,000, 48,000 for the random access mode, okay, to read to end of the file. How about the sequential access? Sequential has taken, so many large number of bytes. It's 8.3 million. It's 8.3 million nanoseconds it's taken to reach the end of the file. Similarly, if I let me do it again, so there is no bias. Okay, it is a 7.5 million nanoseconds. So you see such a big difference between the difference execution time between the random access mode and sequential access mode. So you see it's so awesome. Okay, let me change the mode from character reading to the line by line reading. Actually, the line by line reading is much slower compared to character by character reading, because it has to read entire line. Reading entire line, get line is very slow, because it's in get mode. It's read one character, go to next character, go to next character, and move to next character. Over here it starts the cursor start from start of the line. It keeps reading to end of the line. Okay, and in this, and then fetches the entire line, and then it moves to the next line. Okay, that's why these are different number of operations which get line function perform. That's why it's much slower compared to reading character by character. Okay, so this was the speed test to how to perform, if to evaluate to how much time the sequential access takes and the random access takes in order to reach the end of the file. Okay, so let me perform another speed test. That's I want to search for particular words in that particular file. Okay, so this is my code for the uh, random access, and this is sequential access, search for words. Okay, so the code is same. Okay, so what I'm doing actually, I'm playing with the same file, and I have created an array of size 4 where I have written just any 4 entries. Okay, so because I will be moving to these particular values using the random access mode. So these are different values I've written. So I just want to investigate the time, how much times my cursor takes in order to reach these particular positions. Okay, and I want to independently evaluate the reaching access time to these particular values. Okay, that's why I just open and close it. And definitely this code needs more kind of polishing, which you can do that on your end. But actually, this is the exhaustive code and by exhaustive I mean that there's no logical mistake over here. There is no bias over here towards time. So actually, I only count that. So I only compare the time. So I only compute the time when I perform the seek operation. Okay. So otherwise, because this writing wait see out is not part of the job. Okay, to seek that particular position or to add the time. This adding time means I'm adding the time to access each particular. For example, it takes some time to reach here, some time to reach here. Although I'm reaching those values independently, but at the end of the day, I just want to say how much time it has taken altogether. And similarly, in the sequential access mode, okay, I have to go towards each particular line, and I try to each particular line. I have to check whether I have came across the desired value or not. These are same values, because the data is stored in the form of vectors over there. So that's why I'm created the array of strings. Okay, so I have to evaluate whether the next line contains the desired value or not. Okay, so that's why it gets compared over here. If it's, then it breaks, so that it should not go towards the end of the file. Okay, then it adds the time. Okay, so now let me execute it. Let me check the time for the random access to random access mode. It has taken 200,000 213,972 nanoseconds, and in the case of it's such a big number. Okay, maybe it's 20 million. So you see, first of all, it's a disclaimer that because I am comparing some time for the string matching as well, so it also takes the time. Okay, yes, it also takes the time, but still, but I have to write this code in order to check it. Okay, so whether I have reached that particular line or not. Although yes, I can also check the number of bytes over here, but you can optimize this code uh, but on your own end. So you see, it's further in the random access mode. It's quite small time in nanoseconds, and for the sequential access mode, it's almost 220 million. Okay, so that's why. So the agenda of this program was just to illustrate that how much faster the random access mode is, and compared to sequential access mode, especially at the time of reading the large size file. Although my file which I created was only 540 KB in size, okay, but you can come across the files which are whose size in GBs and terabytes, okay. So that's why uh, you should write the code in the random access mode in order to evaluate or to mine whatever you want to analyze the data, access the data in quickly. So that was it for today's talk. So in this talk, I have explained random access mode in quite sufficient detail. I have also talked about uh, file output formatting. How can I do with multiple files and open the file input and output. And tomorrow I'll talk about the binary binder modes. So that's it for today's. Uh, Please take a good care of yourself. The time is hard for all of us, and we have to take care for ourselves as well as for our the needy person in our locality. Allah